The previous exercise worked for a very simple robot with only two links, but if we had to, do the inverse kinematics of a more complex robot, something like this ABB IRB for 1640, which is a robot with 6 axes. It has, six revolute joints. It has like a wrist joint. It's quite difficult. The previous numerical method of this basic trigonometry, it's just not going to do it. So there is, there is something which is a bit more complex, another more complex way of solving this, which is by using Jacobian matrix, which, don't worry, we are not going to cover this on our lectures. But I think what you should know at the very end of the lab is that in reality, when someone needs to do the inverse kinematics of a robot in order to simulate in an environment or to work with it in the real world, generally people are going to use, software which is already working and doing this instead of writing our own functions by hand. So in the case of Webots, I have this example here with this robot, and I'm using a library which is called ikpy. If you type on Google ikpy inverse kinematics pi, you will go to a project, which is like a complex library which is already going to solve this for us. So basically the idea of this library is that, let's see where the calculation is here. I'm going to provide to this library. This library is going to give me a function which is called inverse kinematics, and I'm going to give to this library like the desired X, Y, and Z locations, and then I'm going to also provide the position of the joints in the robot, and then it's going to magically do all these calculations for me. So for example, you can see in this example here that I'm going to move this black and yellow ball around, and the robot is going to use this library to automatically solve the inverse kinematics. Now I lost the robot, but yeah, oops, I didn't want to do that. So I can move this around, and the robot is going to use this library to do it. So if someday you need to work with a robot for something in particular, like you have been engineers tasked with get a robot to do something, you're not going to do this by hand. You are going to use a library like this one. Imagine that there was a car here and you need the robot to paint from a position XY to a position, AB. So you will provide the coordinates of the position XY, which the coordinates of the position AB, which and the robot is going to automatically do these motions. You can see how the robot is doing crazy things, moving around in order to get our positioning. It's one of the things to consider. But just I wanted to show you how, in the real world, if you were working with real software and real robots, there is no need to solve this, and you can use some software package which is going to solve it for you.